Hi guys, good night everybody. Just let me know if you guys can hear me before I start, please. All right, cool. All right, so I'm hearing people saying they can hear me. All right, so I'm just gonna run through a few examination type questions for you guys. Right. As you all know, the paper is there are going to be 6 questions in the paper, right? And the exam is 2 hours and 40 minutes, right? So in terms of planning, right, you need to spend about, let's say, 20-25 minutes maximum per question, right? In the paper, you can decide to do any question you want first. I suggest you start with the questions that you are most comfortable with first, right? So you can do it in any order. If you're strong in differentiation, go ahead and do differentiation first. If you like integration, do integration first. But it's totally up to you, whatever makes most sense to you guys, right? Just don't spend too long on any one particular question, right? Because 2 hours and 40 minutes is going to fly very, very quickly, right? All right, so let's start, right? I'm going to start with the... Which one was I going to start with first? Right, I was going to start with the question 5, right? Not question 5, sorry, question 6, right? So question 4 is on differentiation, right? And what we need to be able to do, there are several things that can ask us in the differentiation question, right? Let me just get some blank pages here, hold on. All right, so I have 1 or 2 examples here that we're going to look at. So the first one here, we have f of x is equal to x, open brackets, 3 minus x squared, and you want to find this here. Now, in last year's exam paper, a lot of students didn't realize what CSEC was asking for in that question. You guys need to remember that dy dx, right, or your first derivative, can also be written as f prime of x, right? If I want to work out my second derivative, which is d2y dx squared, that's going to be written as f double prime, right? So there's some students who didn't realize that's what they were asking the students to work out in this particular case here, right? So I have f of x is equal to x open brackets minus x squared. Right? Now, if you have a scenario like this, are we trying to find our second derivative? What I would do first, I would probably expand first, right? So in this case, what I will do, I will expand the bracket first. So this is going to be 9 minus 6x plus x squared, right? Now, there are 2 useful identities that you should learn of, right? They come in handy when you're doing the circle question as well. So a plus b squared can be written as a squared plus 2ab plus b squared. That's a very handy identity we could use. Or if we have a minus b squared, that can be written as a squared minus 2ab plus b squared, right? So that's what I'm using here quickly to expand 3 minus x squared. Next thing you're going to do, you're going to remove the brackets. So this is going to be 9x minus 6x squared plus x cubed. Right? So what you've done, you've expanded this here. So this is my f of x. So the question wants us to work out f double prime of x, which is what we call our second derivative. So the first thing you're going to do, you're going to differentiate first one time. So in this case here, when I differentiate this, right, you're going to get 9 minus 12x plus 3x squared. Right? So that's my first derivative. Next thing we're going to do, we're going to find the second derivative, which simply means I'm going to differentiate a second time, right? So when I differentiate 9, I'm going to get 0. When I differentiate minus 12x, you're going to get minus 12. And then when I differentiate 3x squared, you're going to get 6x, right? So this here represents my second derivative, right? right? So this is one simple question that could potentially come in your exam, right? That's our second derivative. Part B, which is a standard question that they bring in the paper, right? I have 3 sine 5x plus 2 cosine 2x, right? And you want to differentiate this. Now, what CSEC tends to do sometimes, they don't normally write it as y is equal to something, and then we have to go find dy dx, right? So what we have to do in this case here, right? You can let y equal that and then find dy dx. It's up to you. Or you could just do this. You can put d over dx, open brackets, all of this. So what that is saying is that we are finding the first derivative of everything inside the bracket there, right? So to do this, all you're going to do, there are some rules for differentiation, right, that you need to know for the exam. If you differentiate sine x, you're going to get cosine x, right? The differential of sine is cosine. If I differentiate cosine x, I'm going to get negative sine x, right? That is basic differentiation. If I have to differentiate sine ax, then it's going to be a cosine ax, right? If I have to differentiate cosine ax, then it's going to be negative a sine ax. So these are some rules that we have to know for the exam, right? You need to know these rules for the exam. So if you want to differentiate 3 sine 5x, the differential of sine is cosine. So this here is going to be, you're not doing anything with this 3. So this here is going to be 5 cosine 5x plus, you're not doing anything with the 2 as yet, leave the 2 right there. When I differentiate cosine 2x, I'm going to get negative 2 sine 2x, right? So in this case, you're going to get 15 cosine 5x minus 4 sine 2x, right? This is a very basic standard question that could pop up in your exam tomorrow, right? Right, so those of you here, just know that this is add maths here, guys. This is not CSEC maths, right? This is CSEC add maths, right? Just letting you know. All right. Right, so this is, that's this part here, right? B part 1. Part 2 now, right? Let me just get some more blank pages here. Right, so this part 2 here, we have 2x plus 3 to the 4th. 2x plus 3 to the power of 4 multiplied by x plus 1. Right? So you want to differentiate this. So this is d on dx, open brackets, all of this. Right? Now, once you can identify 2 functions of x and it's a product, we have to use our product rule. So this here represents one function of x. This represents a second function of x. So there are 2 things I'm going to use here. The first one is this. If I have to differentiate uv, that's a product, it's going to be u dv dx plus v du dx. So that's our product rule. You all need to know this, right? Another rule that I'm going to use here is that if I have to differentiate something that looks like this, d on dx, ax plus b to the power n. When I differentiate this, I'm going to get n a, open brackets, ax plus b to the power n minus 1. Hopefully you all have seen this formula before, right? But that's something that you need to know for the exam, right? All right, somebody's asking about functions. Yeah, no, I haven't done any functions question here, guys. Right? Functions is not on the syllabus. All of this is normal differentiation I'm doing here, right? So, yeah, so like I said, so this is not functions. This is normal differentiation we're doing here. So what I'm going to do, I'm going to apply the product rule. So this is your first function of x. This is your second function of x. So you're going to say the first term, so 2x plus 3 to the power 4. And what you're going to do, you're going to multiply by the differential of the second term, which in this case, when I differentiate x plus 1, I'll get 1 plus, so this is the rule I'm using here, product rule I'm using, plus the second term, which in this case is x plus 1, multiplied by the differential of the first term, this term here, right? Now you have to be careful how you're differentiating that. So let me just do it on the side here for you. 2x plus 3 to the power 4. If you differentiate this, you're going to get 4 multiplied by 2, open brackets, 2x plus 3 cube. So this is going to be 4 2s are 8 by 2x plus 3 cube, right? So that is what I'm going to put here. This is going to be 8 by 2x plus 3 cube. So the final answer now is simply going to be 2x plus 3 to the power 4 plus 8, open brackets, x plus 1 by 2x plus 3 cube, right? Now there's no need to simplify any further, right? Because it's already a little complicated as it is, right? So that's what we're going to do. Right, so that is second part here. The last part here, determine the coordinates of the stationary points on the curve. So this is something that that we can get in an exam question, right? One second, this should have been. Let's make sure it's correct here, guys. Hold on a second. Just give me a sec, right? I said the question here, but I made a change to the question, right? So hold on. I got to type the wrong thing here. 6x squared. Yeah, this should have been at 12. All right, 12 is at 24. Okay, yeah, let's work with this one, right? Let's work with this. So I want to find the coordinates of the stationary point, and I also need to determine the nature of the points, right? So I have y is equal to 2x cubed minus 24x plus x. Plus 4, sorry. Now, if they ask you to find the coordinates of the stationary points in a curve, right, there's a procedure that we need to follow. The first step is to find dy dx. So dy dx in this case here is going to be 6x squared, right, minus 24, right, because the differential of 24x is 24, the differential of 4 is going to be 0, right? So at a stationary point, dy dx equal to 0, right? That's what we know at a stationary point. So all you need to do is you need to put 6x squared minus 24 is equal to 0, right? So 6x squared is equal to 24. X squared is equal to 24 over 6. So x squared is equal to 4. So therefore x is equal to the square root of 4. But in hard maths, as well as in maths, you need to remember that the square root of any number is a positive or a negative value. So in this case here, it's going to be plus or minus 2. So those are my two x values here. You're going to get x is equal to 2. So we need, and we're also going to get x is equal to minus 2, right? So that is two of my possible x values for my stationary points, right? Right, now, what we need to do now, so I literally just did this with my Form 4 maths class, right? So these are my x values of my stationary points, right? So what we need to do, we need to plug those values into your equation of the curve. So in this case here, we're going to say y is equal to 2 by 2 cube minus 24 by 2 plus 4, right? So that's going to give me 2 cube is 8, 8 by 2 is 16, minus, open brackets, 24 by 2 plus 4, and I'm going to get minus 28, right? So this is minus 28 here. So therefore, this turning point here, this first turning point here is, or stationary point, sorry, is going to be 2 minus 28. That's the first point. To get the second point, we're going to substitute this value now, the minus 2. So y is equal to 2 by minus 2 cube minus 24 by minus 2 plus 4. So this is going to be minus 8 multiplied by 2, you get minus 16, minus 24 by minus 2 plus 4, and I'm getting 36, right? You can just double check my answer if you want, make sure we get the same answer. So minus 2, and I'm getting positive 36. Right, so I see somebody put the same things that I have there in the chat, right? That's Michaelia. All right, guys, so let's see what else we have to do here. So all we've done, we've figured out the 2 points, right? The 2 points, and normally you get 5 marks for that in the exam. So the process is differentiate first, right? You're going to differentiate, and once you get that answer, so that's what we did here. We differentiated, that's step 1. The next thing you're going to do when you differentiate, you're going to put that equal to 0. You're going to solve for x. You're going to get, in this case here, I got 2 values of x, right? You have to take those values and plug that back here into your equation of your curve. So therefore, these 2 points here represents my stationary points. Now I have to determine which is a max, which is a min. So what I normally tell my students to do is, here what? We're going to find our second differential. That's the easiest way to do this. So dy dx is 6x squared minus 24. So dy dx is equal to 6x squared minus 24, right? So I'm going to find my second derivative. So d2y dx squared. When I differentiate this, I'm going to get 12x, right? Now, the 2 values of x we got were plus 2 and minus 2. So when x is equal to positive 2, right, d2y dx squared is equal to 12 multiplied by 2, which is 24. Now we're not concerned about the answer here. All we're concerned about is the sign. So this here is a positive number, right? And you all have to remember that when you get a positive number, it is a minimum point. So the point that was 2 minus 28, right, is actually a minimum point. Right? You're getting 5 marks for determining this whole thing here. And we need to use the x is minus 2. d2y dx squared is equal to 12 multiplied by minus 2. You're going to get minus 24. We're not concerned about the value. We're concerned about the sign. It's negative here. So if you get a negative value, so this would have been minus 2. How much we got just now? 30 something. 36. Right? So negative 236. If you get a negative value, it's a maximum point. Alright, so I've seen some people from my class, my Form 5 class here as well, right? Alright, so that's a simple example of a differentiation question that could come in your exam tomorrow, right? So that's a question 5 type question. Let's have a look at a question 5 type question is integration. Let's have a look at this integration question here. Alright, so let's see. In part A, we want to work out this integral here. We have 3 cosine theta minus 5 sine theta. So we're trying to work out the integral of 3 cosine theta minus 5 sine theta. Three cosine theta minus 5 sine theta. All right, so what do we need to know about the integral of trigonometric functions, right? So if you integrate cosine theta, what you're going to get is sine theta plus a constant. If you integrate sine theta, sorry, this should have been theta here, right? You're going to get negative cosine theta plus c, right? So this is what we need to remember when it comes to integrating trigonometric functions. So we're going to integrate this here, and this is simply going to be, when I integrate cosine, I'm going to get sine. So this first one here is just going to be 3 sine theta, right? Now, this is where we have to be a little careful here, because when you integrate sine, you're going to get a negative cosine. So this becomes plus 5 cosine theta plus c. Right? So you have to be a little careful, especially with trigonometric functions, right? Right, so that is part A. So that's an indefinite integral. The second one here is one that gives students trouble sometimes, right? So let me do that on a separate page, 5 minus x cubed. So it's the integral between 2 and 1, 5 minus x cubed dx, right? Now CSEC likes to bring this particular type question, right? Now, some students, when they look at this, they're not sure what to do to calculate this definite integral. Now, the formula that we're using here is this. If we have ax plus b to the power n, and you're integrating this, right? It is going to be ax plus b to the n plus 1, right? All over a by n plus 1. And then we have a constant we need to add, right? So this is the rule, or this is the formula that we're going to use here. But some students, when they look at this, they don't recognize that that's a formula that they're going to use, right? So CSEC kind of throws this in sometimes here to kind of mess with you. But all we're going to do, what I'm going to do first, put my 2, 1 here, but that 5 minus x, I'm going to write it so that it looks like this. So this is going to be minus x plus 5 raised to the power 3 dx. So now it looks like this here, and I can go ahead and use the formula. So this here is going to be, so you put your square brackets, you're going to integrate this, so it's minus x plus 5. This is going to be 4 here, 3 plus 1 is 4, all over a in this case is the coefficient of x, which is minus 1. So this here is going to be minus 1 multiplied by 4. So this is going to be minus 4, right? And the limits of the integration are 2 and 1. So this is a little trick question that could come as well. You got to be careful. Right? So at this stage now, it's just a matter of substituting. So the first one is going to be minus 2 plus 5 raised to the power 4 all over minus 4. Subtract, you're going to substitute 1 now. So this is going to be minus 1 plus 5 to the power 4 all over minus 4. Sorry. Minus 4, right? So in this case here, please use your calculator for these things. Don't stress yourself out. Use your calculator. Minus 2 plus 5 is 3. So that's 3 to the power. That's 81. So this here is going to be 81 over minus 4 minus 1 plus 5 is 4. So that's 4. So that's 256 over minus 4. Right? And when I use my calculator for this, I'm going to get right, so I'm getting 175 over 4. I don't know if anybody could double check that and make sure we get the same thing. Right, so I see, all right, so Krish got the same thing I got there, right, cool. Yes, Joshua, yes, that is true, right? If it's squared, we could just expand it and integrate like normal. But if you have anything greater than 2, that becomes a problem, right? So we had to use that expansion formula there. All right, so I've seen people saying they're getting that, great, right? So that's part B, right? That's part B. Now this part C here now, we want to work out the area of the region bounded by this curve, the x-axis, the y-axis, and the line x is equal to 2. So the curve is 2 plus 5x minus 2x squared. Y is equal to 2 plus 5x minus 2x squared. All right. Now, just by looking at this here, we know it's a quadratic. We know it is going to have a maximum value, right? Now, we don't know exactly how the curve is going to look, right? But just assume something like this, right? So they want us to work out the area bounded by the y-axis, the x-axis, the curve. So therefore, what they're talking about, just on the line x is equal to 2. So let's say the line x equal to 2 is here. So this is 0, this is 2. So the area that they're looking for is this area here. So if you want to work out that area, so the area is simply going to be the integral between 2 and 0, right? And the equation of the curve is 2 plus 5x minus 2x squared dx, right? So again, this is a definite integral. So put your square brackets, integrate 2, you get 2x. Integrate 5x, you get 5x squared over 2 minus, this will be 2x cubed over 3. And the limits here will be 2 and 0, right? So all we're doing here, we're going to substitute 2 and 0 into our integral. So this is going to be 2 by 2 plus 5 by 2 squared over 2 minus 2 by 2 cubed over 3 minus, now if you notice here, every single term here has an x in it. So if I substitute 0, I'll get this, right? Anyway I put 0, I'm going to end up with 0 in the end anyway. So let's work this out here. This is going to be 4 plus 10 minus 2, that's 8, 2 is 16, minus 16 over 3. And I'm getting 26 over 3. And this is area, so we have to put units squared. right? So I seen other people getting 8 and 2/3. Yep, that's looking correct to me, right? Right, so with the integration question, we can get a straightforward integration, right? Either normal integration, trigonometric function. They could ask us to find area, right? They could also ask you guys to work out volume as well, right? I don't have a volume example here, but you need to remember that volume is given by pi integral of y squared dx, right? This formula here is important when you're trying to work out volume, right? The most common mistakes that students make when they're trying to work out volume is that they forget to square the curve that they gave them, right? That's a common mistake that they make. Some students even forget to put the pi in front of it, right? So if you have an area that you're rotating about your x-axis, this is the formula that we're going to use, right? Now, another thing that can come under integration has to do with velocity, velocity, displacement, and acceleration, right? Now, let me just snip this whole question here. Hold on. Right, so you could get a question where we have nonlinear, we have acceleration that is not constant, right? Acceleration is not constant. So we have a particle here, right? And the particle is such that it moves in a straight line. At time t seconds after projection, the velocity of the particle is given by this formula here, right? So you have a formula for velocity. In part 1, they said find the time at which the particle first comes to instantaneous rest, right? Now, this is your velocity equation here, right? If you look at this here, it's a quadratic. So therefore, we know that the curve is going to look like this. Question wants to know at what time, right, does the particle first come to rest? So if your particle is coming to rest here, guys, your velocity has to be equal to 0. So you need to know what these words mean here. So if your velocity is 0, right, you're going to put 2t squared minus 14t plus 12 is equal to 0, right? Now we're going to have to factorize this. So when I have big numbers like this, I divide everything by, let's say, 2. So you'll end up with t squared minus 7t plus 6 is equal to 0. When I factorize this, I'm going to get t, let's say 1, this is 6, right? And you want to get minus 7, so this has to be a minus, this has to be a minus. So therefore, we're going to get t minus 1 is equal to 0. So t is equal to 1. Or we can get t minus 6 is equal to 0. T is equal to 6. So therefore, these are the two times at which our velocity has to be 0, right? But the answer that they want, because they said the first time at which the velocity becomes 0, it is going to be at t equal to 1, right? So this is going to be my answer here, not 6, but 1, because they said first comes to instantaneous rest, right? So that's your answer for part 1. For part 2 now, we want to work out an expression for your displacement. Now to get displacement, and normally we use an s or x, so displacement is your integral of velocity. So in this case here, you have to integrate the velocity formula, which is 2t squared minus 14t plus 12 dt. So we need to integrate this. So when I integrate this, I'm going to get 2t cubed over 3 minus 14t squared over 2 plus 12t. Don't forget your c. You need to include the c here. But I need to simplify some things here first. So this is 2/3 t cubed minus 7t squared plus, sorry, I missed out a t here. This should have been t here. 12t plus c, right? So this is my formula for my displacement, right? Now the problem here is that we need to figure out what c is, right? But we have a piece of information that we could use for that. When t is 1, your velocity was 0, But let me just read something here first. Hold on. Particle is projected from origin such that it moves in a straight line at time t seconds after the projection. Oh, okay. So all we're doing for this part here is when t is equal to 0, the assumption is the displacement is 0. So if I substitute 0 into that formula, I'm going to get this constant here equal to 0. So therefore, the answer is simply going to be S is equal to 2/3 t cubed minus 7t squared plus 12t. That's it. We don't need to do anything else to work that out. Right, I know some, I've seen in the chat here some people wishing for a leak. That's the worst possible thing that could happen, guys. Trust me. I know a lot of people believe that because they're gonna disregard the paper 2 in maths, you're gonna be okay. That's not true. Right? That's not true because CXC is gonna scrutinize your SBA now. Right? So if this paper were to leak, right, and then they're gonna scrutinize your SBA mark for add maths. That's a problem. Right? That's a problem. Right, so that is part 2. So this is part 1. Right, this is part 2. What else we have here? The third part, they want us to work out the acceleration of the particle when t is equal to 3. Right, so that's an easy thing here as well. So when I differentiate velocity, I'm going to get acceleration. So if I have v is equal to 2t squared minus 14t plus 12, right, dv dt is going to be your acceleration. So this is acceleration. So when I differentiate this, I'm going to get 4t minus 14. So all we need to do is to substitute t is equal to 3 into that formula. So when t is equal to 3, a is equal to 14 multiplied by 3. Sorry, 4 multiplied by 3 minus 14. Right, 4 3s are 12, 12 minus 14 is minus 2, and this is acceleration, and this is going to be meters per second squared. All right, so that's my question on integration, right? Now, a lot of people don't pay attention to question 6, right? Question 6 in the exam is going to be on probability and statistics, right? And generally, some people, they don't like to do these questions, right? Sometimes the questions are pretty straightforward though. Let's have a look at one that I have here. All right. All right, so Alexis usually has cricket practice on afternoons. The probability that he studies for his ADMATS exam is 0.6. If he studies, the probability of passing the exam the next day is 0.85. If he doesn't study, the probability of passing the exam is 0.4, right? So there's a strong correlation between studying and actually passing the exam. Now, the first part of the question, right, we want to illustrate this information on a probability tree diagram, right? Now, you guys have to be able to draw a probability tree diagram given that information. So those of you who know how to do it, right, try a thing first before I draw my diagram, right? Alright, I see somebody asking about the definite integrals. Yes, you can work it in the calculator, but you still have to show your working, guys. Right? So you actually will want to see the working. You can use the calculator to double check your answer. right? So Alexis usually has cricket practice on afternoons. The probability that he studies for his ADMAT exam is 0.6. If he studies, the probability that he passes the exam is going to be 0.85. If he doesn't study, probability of passing the exam is 0.4. Yeah, if you all get a probability, if you all get a stem and leaf diagram, that's a easy question, right? Right, so you're trying to draw a probability tree diagram before I draw it, right? Let me see if you yeah, question 6 is reasonable if you know what you're doing, right? Right, somebody's asking about standard deviation and stem and leaf diagrams. Yeah, you can get that as well, right? All right, so some people saying they finished, so let me start a draw it, right? Because I have limited time, right? So in this case here, all right, so let's start. Okay, first things first, right? So remember, you're drawing a probability tree, right? So you have a starting point here, right? And he can either study or not study, right? So we do this here, right? And if he studies, right, he can pass or he can fail, right? So in this case here, let's put study here. Right, let's put does not study. Right, so let me just see the probabilities again. Right, so the probability that he studies for the ADMAT exam is 0.6. So this here is going to be 0.6. That's the probability of him studying. So if he doesn't study, that probability has to be 0.4, right? 1 minus 0.6. Now if he studies now, he has two things that can happen. He can either pass or he can either fail. Right? Same thing here. If he doesn't study, again, he can pass or he can fail. Right? So I just need to put in the probabilities there. So if he studied, let's see, if he studies, probability of passing is 0.85. Right? So this here is 0.85. So if he studies, probability of passing is 0.85, and this one here is going to be 1 minus that, so that's 0.15, right? So we've worked out the probabilities. When you're drawing a probability tree, you must include all your probabilities, right? So in the next one here now, we said if he doesn't study, probability of passing is 0.4. So therefore, this here is going to be 0.4, and therefore this has to be 0.6. Did you get a diagram looking like that? Just let me know if your diagram look like this. Right, some people saying yes, right? So we'll work with this diagram here, right? People saying yes, right? So that is the answer for part A. Part B now, we have some probabilities to calculate. calculate the probability that Alexis studies and passes the exam. So once you have a probability tree diagram, guys, it is very easy to work out the probabilities. So the question says, let's go back here. So he studies and he passes the exam. So if he studies, go to the diagram, that means he went this route. He studied and he passed the exam. So all you need to do, the answer for that first part there, right, where he studies and he passes, so studies and he passes the exam, it's going to be 0.6 multiplied by 0.85. It's as simple as that, right? 0.6 multiplied by 0.85, and you're going to get 0.51. Right? That's your probability there. Right? So that's the answer for the first part. That's this part here. Now, the second part, calculate the probability that Alexis passes the exam. Now, if we go to the diagram, we have to look and see all the options where he can pass the exam. So he can study and still pass, or he doesn't have to study and he could still pass. So there are two possibilities that we have to look at here, this one and this one here, right? So that probability that they want in the second part, that he passes, probability that he passes, you have two options. He could study, which is 0.6 multiplied by 0.85. He could study and he could pass, right? Or we have an alternative as well. He could not study, which is 0.4 multiplied by a next 0.4, right? So those are the two options where he can pass. So that's going to be 0.51 plus 0.4 by 0.4, and you're going to get 0.67. Right, I hope that those probabilities making sense. Yes, basically we're finding all the combinations and we're adding up those probabilities, right? All of those are possibilities that you can get, right? So that is the answer for him passing, right? Normally when they give us a probability tree, there may be a conditional probability somewhere inside it, right? So this part C here, given, and this is the word that you're looking for. Once you see this word given here, that's a conditional probability. Right? So given that Alexis passes the exam, calculate the probability that he studied for the exam, right? So you have to be careful how you're writing this too, right? You have to be careful how you're writing this. So basically, let's give it some names, right? Given that he passes the exam, let's call that P, right? And calculated that he studied, let's call that S, right? So we have P and we have S. So in terms of probabilities, right? So we want to find the probability that Alexis passes the exam given that he studied for the exam, right? Sorry, I'm reading wrong. Given that Alexis passed, right? So he passes the exam given that he studied for the exam, right? So I hope that's making sense. The probability that we're working out is S given P. Right? That's the probability that we're working out based on his statement. Right? We know that he passes the exam. We're calculating the probability that he actually studied for the exam. So the formula for conditional probability will be this. S intersect P over the probability of P. Now, this probability on top here, S intersect P, right, means that he studied and he passed the exam, right? So let's have a look at those probabilities there. Right, so studied and pass would be, let's go back up here. Studied and pass would be this probability by this. which is this 0.51 that we just got. Right, so this is going to be 0.51 over the probability that he passes the exam. The probability that he passes the exam, we just worked that out and we got this. We got 0.67, right? So it's going to be 0.51 divided by 0.67. And you're going to get 0.76, right? 0.76. Right? Now, you can get probability trees, you can get Venn diagrams, right? We can't say for certain what is actually going to come tomorrow, right? So all I'm doing here is some sample questions, guys, right? Can't teach you everything in AdMaths in one night, right? My exam preparation lasts months, right? So we have a table here. We have some data. The scores from an AdMaths exam are shown in the table above, right? So we gave our class an AdMaths exam, and we want to draw, first of all, a stem and leaf diagram to represent the data in this table here. All right, let me get this on a separate sheet up here. All right, now we have some data here and we want to draw a stem and leaf diagram, right? Now you see, if CSEC gives us the data mixed up, that is going to be a little problematic. What I've done here, I have the data, but I have the data in ascending order to make our life easier, right? So what you're going to do, even if the data was mixed up, what you need to do is to find the smallest data. So the smallest data in my table here is 30. The largest data in my table here is 81. So what I will do to draw the stem and leaf diagram, I'll have my stem, right? We have leaf across here, right? And the numbers that we have, so the first one, let's go with a stem of 3. And we're going right up to 8. 4, 5, 6, 7, 8. Right? So remember, use your ruler to make sure draw some lines here. Right? Now, what you're going to do, you're going to go to the table and you're going to pull or extract the information. So the first one here was 30. So you're going to put a 0 here. Next one here is 31. So you put in a 1 here. Then we have 32. So you put a 2 here. Right? And we keep going. Right? We keep going. The next one is 42. So we're going to put a 2 here. Then we have 44. We have a 5. Right? 45. So we have this, we have this, we have this. Next one is 57, then 58. So we have a 57 and we have a 58. Right, so we take care of this. Then we jump to 62. Well, we have 62 appearing twice. So 62, 62. So that's this. Then we have two 63s. So you have this, and then we have 1, 2, 3, 4. 4 64s. 1, 2, 3, 4. Right, and then we have a 66. We have 266. Right, then we have 67. 67. Right, and then we have a 68. Right, and then we have two 69s. Right, so a lot of people in this class got any 60s here for this AdMaths exam. Next thing we have 71, so we put a 1 here. We have a 73. Then we have a 76. And then we have a 81. Right? So this here represents my stem and leaf diagram here. Right? Just remember, when you put your stem and leaf diagram, right, you need to give a key. Right? So my key, I mean, you could use any one that you want. So let's say if I put 4/2, you're going to tell them what that means. Means 42. right? So please, when you draw a stem and leaf diagram, please indicate what the key is, right? Right? So this is your answer for the first part. Draw a stem and leaf diagram, right, to illustrate the data. The next thing that we want to do here, we want to draw a box and whisker plot to illustrate the data, right? Now, a box and whisker plot, right, basically is a 5-number summary diagram, right? So there are certain pieces of information I need to determine first before I can do this, right? So to draw a box and whisker plot, this is what it looks like. You have a box, right? The box has one number here, it has a number here, it has a number here. So that's 3 numbers. And it also has your minimum value, and it also has your maximum value. So this is what a box and whisker plot looks like. Now this box and whisker could be horizontal or it could be vertical. It depends on how they draw it in the exam, right? So what we need to do, this is your minimum value, this is your maximum value, right? So therefore we already know what those values are. This is 30 and this is 81. So this has to be 30, this has to be 81. Next thing we need to do, this value here is your lower quartile, Q1. This here is your median, and this here is your upper quartile, right? So we need to figure out those numbers before I could even draw this thing. So let's go to this here. Let me see if you all can figure that out for me. I want to know what is Q1. I need to know what is Q2. So put on Q1 for me in the chat, Q2, and I also need to know what is Q3. Because if you can't figure out those numbers, then you can't draw the diagram. Eh? Look at the diagram and let me see if you could come up with something here. What is Q1? Right, I've seen some answers coming in here, right? You're all getting similar answers, which is good. Right, somebody's asking about CSEC advanced questions repeat. It's not so much that they repeat, but they have a style in which they bring the questions. So the questions may look very similar to what came in the past, right? All right, so I see let me see here. Seeing Joshua, Sodakan, Krish. Right, so I've seen a lot of people having the same answers, which is good. It means that you all know what you're doing, right? Because they like to bring this question, they like to bring this. Now, whenever you're trying to work out your quartiles, the first thing you need to do is to ask yourself. You have to look at the data, right? Now, there are 2 ways we can work this out. We can look at the data from this table here, or you can look at the stem and leaf diagram. Doesn't really matter, right? But the first thing you should do is to identify how many scores do we have, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 threes are 27. So you have a total of 27 scores, right? What you have to do is to ask yourself, is that an odd or an even number? Because if it's an even number, there's no exact middle, right? But if it's an odd number, then sure, we're going to have an exact middle. So if we have 27, so you have 27 scores, right? So we need to know how to break this up, right? So if you have 27 scores, right, you need to find half of 27, right? That's going to give you what? 13 and a half. So that means that your 14th score is going to be your median, right? So let's check this. Let's go to the diagram, right? I'm going to use this stem and leaf here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this here is your middle score. And you can check above and below and make sure you have the same number of scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So therefore, this value here is definitely going to be my median, right? But that median there is not 4, but it's going to be 64, right? So your Q2 in this case is going to be 64. This number here is 64, not 4, but 64. Now you're going to check. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 is an odd number as well. So therefore, we can find an exact middle of the numbers below 64. So that is going to be 13 divided by 2 is 6.5. So we're looking for our 7th score. 1, 2, 3, 4, 5, 6, 7. So this here is going to correspond to Q1. This here is 57. That is what Q1 is, right? Which is, I think, what you guys had. And the last thing now, we need to find the upper quartile, which is going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Hold on, let me check this over. 1, 2, 3, 4, 5, 6. 1, 2. Yeah, so the upper quartile in this case is going to be 68. Yes, if you go through all the exam papers, which is not really much, you should be ready for tomorrow. All right, so I see you guys get the same answers that I have here. So now what we're going to do, and this is one of the things that I don't like that CSEC does for us. They want us to sketch the box and whisker plot. But ideally, you should draw a box and whisker plot on a graph paper, right? Ideally. But what I've told my students to do, right? Since you're going from, these are your values. The minimum value is 30. So the minimum value is 30, right? The Q1, Q2, Q3, and max. So the max value was 81, 57, this is 81. Q1 was 57, so 57, 64, 68. 57, 64, 68. Right? So these are our values here. Those are our 5 numbers we need to put on this diagram. So what I told them to do is to draw a little scale here, draw it in pencil, right? So let's say this is 30, 40, 50, 60, 70, 80, right? You're doing a rough diagram here, right? So that's 30. Now the smallest value we have is 30. So you're going to put that here. You're going to put 30 here, right? The next value is 57. So this is 30, 40, 50, this is 60. So 57, put in an approximate location of this. So that's 57 here, right? The next value, so we have this. Next one is 64. So 64 might be about here, so. Right? And then 68 now. So 68 is going to be right here. Right? And then the last figure is 81. So this 81 should be about here, so. Right? So all you need to do, take a ruler, draw this, do this, do this. Now, what's he actually giving you the marks for? You need to put in these numbers. So 57 here, 64 here, and then we have 68 here. Right? So label this as Q1, label this as Q2, and label this as Q3. Right? Because CXC, this is how CXC is going to mark it. They're looking to see where you have put Q1, Q2, and Q3. Now, the next part, normally, right? Normally what we do, let's see what they're asking for here next. Comment on the skewness of the data. So they love to bring this, right? Look at the data, and could anybody tell me what can we say about the skewness of the data? What can we say about the skewness of the data? All right, somebody's asking what year is this, right? This is my exam paper, right? Right, I've done all the past papers with my students in my class, so trying to do something different this time here, right? Right, so some people saying negative, well, a lot of people saying negatively skewed, right? I tend to agree with that as well, right? So when it comes to the skewness of data, data could either be positively skewed, right? It could be negatively skewed, right? It could also be normally distributed, right? Or the better word here, let's put symmetrical, right? So those are my words that we want to see in an exam question, right? Now, if you just look at the diagram here, right? The best thing to do is to look at the spacing between Q1 and Q2. Look at that spacing here and look at the spacing here. When you look at the diagram, you realize the spacing between Q1 and Q2 seems to be bigger than the spacing between Q2 and Q3. When you have a spacing on the left that is bigger, this here means that the data is negatively skewed, right? So this data here is negatively skewed. That's the answer. Right, so that's box and whisker, and that's stem and leaf that you need to know for the exam. The last part here, state one advantage of a stem and leaf diagram over a box and whisker plot. That's something that comes as well. What is the advantage of having a stem and leaf over a box and whisker? Anybody know that? My students who are here should know that, right? Yes, Ray, that is true. If Q2, the spacing between Q2 and Q3 is bigger, it's positively skewed. And symmetrical is when the spacing between two of them is around the same. Right, so I've seen Emma, Joshua, several people saying all the scores can be seen. That is true. In a stem and leaf diagram, you retain your raw data. The raw data is in that table, right? A box and whisker plot, like we said, is a 5 summary diagram. It doesn't have the original data in it. That's a problem, right? So one advantage, right? Your original data is preserved. Right? That's what's happening here. Yes, we can. Right. So some people have some other answers. The mode can be determined. Yes, you can easily see what the mode is. You can also, on the diagram, you can see your distribution of the data. You can tell about the skewness based on a stem and leaf diagram, right? Another thing is that you can, once you have the raw data, you can calculate things like mean and standard deviation, right? Alright, so if you all haven't done so as yet, guys, please remember to hit like and subscribe, right? Don't forget to do that. Please hit like and subscribe. Now, they haven't brought a question like this in a while, so I have one here just in case it shows up tomorrow. So I have the length of 5 leaves in centimeters as shown below. We want to calculate the mean and we want to calculate the standard deviation, right? So first things first, part A, calculating the mean is very easy. So mean, which is x bar, is simply sigma x over n. So in this case here, we're going to add up all these scores. So this is, not scores, sorry, the lengths, 6.9 plus 7.2 plus 7.5 plus 7.9 plus 8.5. And you're going to divide all of that by 5. 1, 2, 3, 4, 5. Yeah. Right, I'm getting 7.6 as my mean. You all could just double check that answer for me here. Right, so yeah, so some people getting 7.6, yeah, that's what I'm getting as well, right? So that's your x bar. Now, calculating the mean is very straightforward. Standard deviation, on the other hand, we need to draw up a little table, right? So what you're going to do, and let's hope that they only give us a few numbers, because if they give you a lot, then the calculation becomes a little lengthy, right? So the first thing that we're going to do, we're going to write down all the values here, 6.9, 7.2, 7.5, 7.9, and 8.5. Right? Those are my values for x. Next thing you're going to do, you're going to work out x minus x bar. So that's why we need to know what the mean is, because you need mean in order to calculate standard deviation. Next thing you're going to have a next column here called x minus x bar squared. Right? So let's hope if you get something like this, it's a very short question, hopefully. So what you're going to do, you're going to take every value of x here and you're going to subtract what the mean is, which is 7.6. So 6.9 minus 7.6, you're going to get negative 0.7. And I'm going to square that one time. So that's going to be 0.49. Right? So we have to do this for all of the points. So 7.2 minus 7.6, you're going to get negative 0.4. Then we have to square that. You're going to get 0.16. Next one is going to be 7.5 minus 7.6. You're going to get negative 0.1. Then we have to square that. You're going to get 0.01. Next one is 7.9 minus 7.6. You're going to get 0.3. Right? We have to square that. You're going to get 0.09. And then the last one here is 8.5 minus 7.6. You're going to get 0.9. Then we have to square that. And you're going to get 0.81. Right? So what we need to do here, or what we need to get from this table is this. We need to actually sum this column here. Right? So that is going to be 0.49 plus 0.16 plus 0.01 plus 0.09 plus 0.81, and you're going to get 1.56. Right? That's what we're going to get at 1.56. Right? I hope that I hope that making some kind of sense to you all. Right? So you want to get standard deviation, right? Standard deviation now is simply sigma x minus x bar squared over n. So in this case here, it is going to be 1.56, right, over, how many you have there? 5. Which is 0.32, 312. Right, I hope that making some sense there. Right, just now, I just realized I forgot to put the square root, yes? So it has to be this, my bad, forget the square root. Right, somebody's asking about, yes, right, so you're all saying variance, yeah. So I forgot the square root there, right? So with the square root, that is your standard deviation, right? If I left out the square root, that is variance, right? Right, those of you doing paper 3, make sure you know differentiation extremely well, right? Differentiation comes a lot in that paper 3. Right, so I've done 3 types of questions here for you all. I've done a differentiation, I've done an integration, and I've done a statistics question, right? Now, something that is going to come for sure in your exam is circles, right? You're definitely going to get a question on a circle, right? And that particular question, that's number 3 in the paper. This can come in several different ways, right? So in this question here, I have an equation of a circle, and what we want to work out, what is the center of the circle and what is the length of the radius, right? So first things first, there's the general form of a circle given by x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. Right? So that's a general form of an equation of a circle, right? Now, what we're going to do, we're going to compare this general form with what they gave us here. We're going to use that to figure out what is f and what is g, right? So in this case here, let's write out x squared plus y squared plus 2fx plus 2gy plus c is equal to 0. So that's your general form, and we have this. X squared plus y squared plus 10x minus 6y plus 9 is equal to 0, right? Now what that does here, we can compare coefficients, and we can say that 2f is equal to 10, so f is equal to 10 over 2, so f is equal to 5. Next thing we're going to say is that 2g is equal to minus 6. So therefore g is equal to minus 6 over 2. So g is equal to minus 3. Right? Now this is where things get a little confusing for students, because when you have a circle in this format here, your center is given by minus f minus g, right? And your radius is equal to f squared plus g squared minus c square root, right? So you need to remember that if you are given the equation of a circle, we will assume that the center is minus f minus g. So the center of the circle here is going to be minus 5, positive 6. That's going to be the center of the circle here. Sorry, positive 3, right? Positive 3, my bad. Right, this is 3. Right, so it's minus 5, positive 3. That's the center. So the radius now is given by that formula there. So it's going to be 5 squared plus minus 3 squared minus whatever c is. C in this case has to be 9. Right, minus 9, and you find the square root. So this is going to be 5 5s are 25, 3 3s are 9, minus 9. So this here is the square root of 25. So therefore this is 5 units. Right? So that's your center and that's your radius. Radius is 5 units and the center is minus 5, positive 3. And they like to bring this question a lot. They want us to determine the equation of the tangent to the circle at the point minus 1 6. Right? Get a blank page here. So it's one of two things they're going to bring tomorrow. Either they're going to bring a tangent or they're going to bring a normal. One of the two. Right? So you have a circle. Now this is just for understanding purposes. You have the center, right? We know what the center is. You have a point on the circle given by, what's that point? Minus 1 6, right? We don't really care what that point is, right? So let's say this is minus 1 6, right? The center of the circle, we got minus 5, positive 3. Minus 5, positive 3, right? So this here represents your radius. This here represents your tangent, and this is what they want us to work out. What is the equation of this tangent here? So several steps we need to take here. First thing we can do, we can find the gradient of this line here. This what they call the normal or the radius. I could work out the gradient, right? So the gradient m is equal to y2 minus y1 over x2 minus x1. I know some students learn off a formula. I don't really like to learn off formulas. So I'm just going to label it like this. Call this x1, y1. Call this x2, y2. So you just substitute it now into this formula. So this is going to be 6 minus 3 over minus 1 minus 5. Sorry, minus 1 minus 5. So 6 minus 3 is going to give you positive 3. Minus 1 plus 5 is going to give me 4. So therefore, that means that the gradient of the normal is equal to 3/4. So therefore, I can use that information to work out the gradient of the tangent. Right, so I've seen people saying yes. When you're trying to work out the gradient of the tangent, it's very easy to mess that up in true. Eh? So the gradient of the tangent right is going to be minus 4 over 3. That's your gradient of your tangent, right? So you know the gradient of the tangent, and this is the part that students make a mistake with, right? When you're finding the gradient of the tangent passes through this point. It doesn't pass through the center. So the point that you're going to have to use in your calculation is minus 1 6. So we can use the formula y minus y1 is equal to m into x minus x1. Right? Whatever method you have to work out the formula, that's okay. So it's going to be y minus 6 is equal to minus 4 over 3 multiplied by x minus minus 1. So therefore, y minus 6 is equal to minus 4 over 3x. Right? This is x plus 1, so this is going to be minus 4 over 3. So therefore, y is equal to minus 4 over 3x. Right? minus 4 over 3 plus 6. So I'm getting plus 14 over 3. Right? Now you can leave your answer like this, or some people like to show that they know what they're doing. So you can also write your answer as 3y is equal to minus 4x plus 14. Or you can write your answer as 3y plus 4x is equal to 14. Right? All of these are possible ways of writing your answer. Right, so that is circle geometry, right? Not going to do every single possibility here. I'm just going to do one example. The next thing here that will come as your question 3 is vectors, right? Vectors fall into this question as well, right? We have two position vectors, OA and OB, and we want to determine the vector AB. So always draw a quick sketch when it comes to things like this. So this is O here. OA is 7, 5. So let's say this is A up here, right? So this is OA. Next one is 6 minus 2. So that's maybe somewhere down here. So I'm just putting approximate positions, right? Now, first part of the question, we want the vector AB. So this here is your AB. So you're driving a car. Think of it like that. So AB is simply going from A to O, and then you're going from O to B. A to O is the reverse of this vector. So this is going to be minus 7 minus 5 plus OB, which is 6 minus 2. So minus 7 plus 6 is going to give you minus 1, and then minus 5 plus minus 2, you're going to get minus 7, right? So that's my vector AB here. Right, so this one is not too bad, right? The second part here, they can ask us to find the angle between two vectors, right? That's something that they like to bring to, find the angle between two vectors. So let's draw a little sketch here. So this is O, this is A, this is B down here, right? And the question wants us to work out the angle between these two vectors here, right? OA is 7, 5. OB is 6 minus 2. Right, so those are two vectors here, right? So the formula that we're using, and it's normally written like this in the exam, A dot B is equal to modulus of A modulus of B cosine theta, right? So you have to know how to use the formula. So what I would do first, I would work out A dot B, right? Or OA dot OB, right? So there's a dot product you're working out, 7, 5 dot 6 minus 2. So that is the same as saying 7 multiplied by 6 plus 5 multiplied by minus 2. So that is 42 minus 10, so that's 32. Right, so your dot product here is 32. Next thing we need to do, we need to find the magnitude of OA. So we're using Pythagoras' theorem here. So this is 7 squared plus 5 squared square root, right? So that's 49 plus 25, that's 74. So we can leave this as the square root of 74 for now, right? And then we work out OB, which is 6 squared plus minus 2 squared, square root, and that's going to be 36 plus 4, so that's the square root of 40, right? Now, if we're using this formula here to work out the angle, right, we can say that cosine the angle is the dot product, which is going to be 32, over root 74 multiplied by root 40. So therefore cosine theta is equal to, so that's 32 divided by square root of 74 multiplied by second function square root of 40. So we're going to get 0.588. So therefore theta is arc cos 0.588. So theta is equal to about 54 degrees. Yeah, 10 might be my cutoff limit, guys, or even before, but we'll see. Right? So be prepared to answer a question involving the angle between two vectors. That's something that can come in the exam, right? That's something that can come. Right? But I'm getting 54 degrees as my angle. Now here's the thing, right? If in the exam they tell you to prove that two vectors are perpendicular, just remember that the dot product should be equal to 0, right? So if two vectors are perpendicular, your dot product needs to be 0, right? And in terms of how much is required for the proof, look and see how many marks they're giving you for this, right? Right? See how many marks they're giving you for this. Because if it's a 2 marks, then just work out the dot product. If it's not, then you have to go through the procedure to show that the angle is 90 degrees, right? Now this third question in the exam is one that I don't necessarily like much because there's a lot of information that they try to cram in this one question, right? So I have my example here, my question here. And this one is based on sectors, right? This one is based on sectors. So the diagram shows a sector of a circle with center O and radius 10 cm. OPB is a straight line and is perpendicular to AP, right? So we have an angle there in radians, which is pi over 6, and we want to calculate the perimeter of the shaded region. Now, this question may look simple, but it's not that simple. This here is your center of the circle, this point A here, so therefore this 10 cm is your radius of the circle. From O to this point here, O to B, that is also going to be 10 cm. That's a radius as well, right? So that's as much as we know in the question. Now, we also know the angle here. So if you want to work out the perimeter of the shaded region, you have to find this here. You have to find this curved piece, right? And we know how to find that curved piece here. There's a formula. Length of arc is equal to r theta. In this case, my radius is 10, and your theta is pi over 6, right? So that's 10 multiplied by pi over 6. And you're going to get about 5.24. So this here is 5.24 cm, right? That's that length there. Now, what we need though, we need to work out, we need to know this vertical height here, right? You need this vertical height here. The only way you're going to get that vertical height here is by using some trigonometry in order to do that, right? So you have a right angle triangle. That's a white triangle there. So this side is your opposite that you're trying to figure out. This side here is your hypotenuse, right? So therefore we can use tan here. So tan theta is, sorry, not saying the wrong thing, yes? Its opposite is hypotenuse, right? So it's sine. Sine theta is opposite over hypotenuse, right? So sine pi on 6 is equal to opposite, which is AP, right? All over your hypotenuse, which is 10. So therefore AP is equal to 10 multiplied by sine pi on 6. Now you see when you're doing these trigonometry questions, make sure you're using a calculator in the correct mode, right? What I normally do So I know that pi on 6 is 180 over 6, so that's 30 degrees. So in my calculator, I'm going to press 10 multiplied by sine 30, because my calculator is in degrees right now, and I'm going to get 5. So the length of this thing here is going to be 5 cm. So this here, the height of this thing is 5 cm, right? Now, so we have two dimensions for that shaded region, right? So this is 5. The other part there is 5.24. The next thing we need to work out, I need to work out this length here, right? Because remember, we're trying to work out the perimeter of this thing. So I need to know this length here. And if I know that, I can subtract it from 10 in order to get PB, right? I hope that's making some sense. So what I'm going to do to work out that length OP, I'm going to use Pythagoras' theorem. So I'm going to say, how will I do this by? I'll say OP squared plus 5 squared is equal to 10 squared, right? So OP squared is 10 squared minus 5 squared. So the length OP is equal to the square root of 10 squared minus 5 squared. So you see, I told you the question, it look easy, but it's not that simple. 100 minus 25, second function, square root. You're getting about 8.66. Right? So that is OP. But PB now is going to be 10 minus 8.66. And you're going to get 1.34. Right? So, in terms of finding the perimeter of the shaded region, right, there were 3 lengths that we needed to work out. We needed this curved piece here. We needed to get AP, which is this here, that's 5 cm. And we also needed to get our length PB here. So now, to get the perimeter, all you need to do is to add up those numbers. So that's going to be 5 plus 5.24 plus 1.34, and you're going to get 11.58. Right? As in, you're talking about degrees and radians, right? Make sure whatever method you're comfortable with, go ahead with that, right? For me, I like to keep my calculator in degrees, and I'll just convert the angle into degrees and then work from there, right? But that's just me. Right? Somebody's asking about the formula for a sector. It's a half r squared theta. Right? So the next thing that we want here now, we want to work out what is the area of the shaded region, right? So the area of the shaded region, all you need to do is to find the area of the whole sector and minus the area of the triangle. That's all you need to do. Area of sector minus the area of the triangle. Now the thing is, this is 10 cm. OP was, this here is 8.66. Right? Yeah, that makes sense. 8.66 is OP, right? So the first thing I'm going to do, I'm going to find the area of the sector, right? So the area of sector is equal to a half r squared theta. That's the formula. So it's a half multiplied by the radius was 10 multiplied by pi on, what else? Pi on 3, pi on 6. Right, so this is going to be 50 multiplied by pi over 6, and you're going to get about 26.18 cm squared. That's the area of the sector, the whole sector. Next thing I need to do is to find the area of the triangle. Right, so it's a triangle, a right angle triangle, so you could use a half base by height. Right, because I think we have all those lengths. Let me see. Right, so the base is 8.66 and the height is 5. So that's 0.5 by 8.66 by 5. And you're going to get 21.65. Right? So therefore, the area of the shaded region is simply going to be 26.18 minus 21.65. And you're going to get 4.53. Right, so I'm getting something like about 4.5. Somebody said to develop an accent, a Trinidadian accent. All right, so this is something that could come. You need to know your formulas for length of arc, and you need to know your formulas for area of a sector, right? So let's see, what are we going to do now? Right, so that takes care of question 3 minus trigonometry inside there, right? Because I think the question I have here is too simple. I think it's too simple. Let's have a look at this question here, which can come as question 1 or question 2 in your paper. Right? We need to know about the remainder theorem and the factor theorem, right? I have, hey, what happened here? It should be squared. Yeah, I have a function, right? It's given by ax cubed plus 5x squared minus bx minus 18. It has a factor of x minus 2 and leaves a remainder of minus 20 when divided by x minus 1. Calculate the values of a and b. Now these questions, even though they may look simple, you need to be very careful when you're working out these things. So you have a function f of x, right? And they are telling us that this is a factor here. Now if they told us that this is a factor, it means that when I divide it by x minus 2, I am not going to get a remainder. So that means that f of 2 has to be equal to 0. That's what that is telling me. If it's a factor, then f of 2 is equal to 0. Then they told me that I'm getting a remainder of minus 20 when I divide by x minus 1. So what that means is that f of 1 is equal to minus 20. So I have to use those two pieces of information in order to solve for whatever a is and whatever b is. I don't know what they are, but I need to figure them out. So here's what you would do in a scenario like this. F of x, you write down the equation first of all, ax cubed plus 5x squared minus bx minus 18, right? So we're going to start with, let's do the factor 1 first. So f of 2 is going to be a multiplied by 2 cubed plus 5 by 2 squared minus b by 2 minus 18. But that has to be equal to 0, right? That has to be equal to 0. So 2 cubed is 8. So this is 8a. Plus 2 to the 4 by 5, that's 20, minus 2b minus 18 is equal to 0. So we can write this as 8a minus 2b is equal to, this is 18 minus 20, this is minus 2, right? So this here represents one equation that we have. Next thing we're going to do, we're going to find f of 1. So f of 1 f of 1 is going to be a by 1 cubed plus 5 by 1 squared minus b by 1 minus 18 is equal to minus 20, right? So 1 cubed is 1, so this is a plus 5 minus b minus 18 is equal to minus 20. So we can say that A minus B is equal to minus 20 plus 18 minus 5. You're going to get minus 7. Hopefully I have no errors there, right? Hopefully. All right, so how are we going to solve this? Well, what we can do, we could just do substitution if we want, right? I could say that A is minus 7 plus B, right? I can take this and I can substitute it across here, right? Let me try that. Like I said, hopefully I have no errors. Sometimes when you work in these questions, you can make errors very easily. So 8A minus 2B, 8A minus 2B is equal to minus 2, right? And the other equation that we have is A is equal to minus 7 plus B, right? So I'm going to take this and substitute into this equation. So this is going to be 8 by minus 7 plus B minus 2B is equal to minus 2. This is minus 56 plus 8b minus 2b is equal to minus 2. So 8b minus 2b is equal to minus 2 plus 56. So therefore 6b is equal to, this is 54, right? So b is equal to 54 over 6. So b is equal to 9. So we get a nice answer here, 9. So therefore A is simply going to be minus 7 plus 9. So A is equal to 2, right? So that's it. Whenever you have a question like that, it is going to be a simultaneous equation in order to work this out, right? Right, so that's something very basic we could get on that, right? Next thing I have here, one second guys, my file is playing the fool again. Give me one sec. one of the things that you all have to make sure you know how to do is to rationalize, right? Right, somebody's asking about the question with the sectors, right? Guys, all I did there was use normal formula for the area of a triangle. Half base by height, that's it. That's all I use, right? All right, let me just show you how to rationalize something like this, right? You all need to be able to do this in the exam, right? Let's say you wanted to rationalize this. What that means is that I need to get rid of my square root in the denominator. So to do something like this, all you're going to do is to say 5 minus root x over 2 plus root x. We're going to multiply by what we call the conjugate. So this is going to be 2 minus root x here over 2 minus root x, right? So what you're going to do on the numerator, it's going to be 5 minus root x multiplied by 2 minus root x. At the bottom now, whenever you multiply by the conjugate, what you're really doing is you're going to use the difference of two squares at the bottom. So this is going to be 2 squared minus square root of x squared, in which case this is going to be, you're going to multiply the bracket on top. So that's going to be 10, right, minus 2 root x minus 5 root x, right, plus x all over, this is going to be 4 minus x at the bottom here. So therefore this is going to be 10 plus x minus 7 root x all over 4 minus x, right? So you have to be able to rationalize any function or any expression that they give us in the exam, right? Right, so if you're getting something like this, it won't be that much, right? This is more than likely definitely 100% common, right? They love to complete the square. They love to bring questions involving completing the square, right? So this is the quadratic function here, and they want me to write it in this format here. So for this particular question here, you can use whatever method you are comfortable with. Some people have their techniques, right? This is my technique for working this out. So the first thing that I'm going to do here is to factor out this 3. So therefore this becomes x squared minus 4x plus 7 over 3. Right? That's step 1. I factor out whatever is in front of the x squared. Next thing I'm going to do now, I'm going to leave this 3 on the outside. Inside the bracket, this is going to be x minus a half of whatever this number is here. So that's going to be 2 squared. You're going to write back the 7 over 3. Minus this number here squared, so that's going to be 4, close brackets. So this is going to be 3, open brackets, x minus 2 squared, 7 over 3 minus 4 is equal to minus 5 over 3. And then the final step is to multiply by 3 now. So this becomes 3, open brackets, x minus 2 squared minus 5, right? And this here is your final answer. So make sure you know how to complete the square. They love to bring that, right? Right, so that's your answer for part A, right? For part B, we want to solve this equation. So whenever they ask you to solve the equation, all you're going to do, since you completed the square already, you're going to do this. 3 by x minus 2 squared minus 5 is equal to 0. So 3 by x minus 2 squared is equal to 5. So therefore x minus 2 squared is equal to 5 over 3. So x minus 2 is equal to plus or minus square root of 5 over 3. So therefore x is equal to plus or minus root 5 over 3 plus 2. So you're going to get two solutions here. So the first solution, we're going to take the positive value. So that's second function, square root of 5 over 3 plus 2. Right, you're going to get a decimal. I'm getting 3.29. The second solution, you're going to take the negative value. So that's second function, square root of 5 over 3 multiplied by negative 1 plus 2. And you're going to get 0.71. Right? So this is it. These are my two solutions for this answer here. Right? Once you complete the square, it's very easy to solve the equation. Right? Right? So that is the answer for that part there. The last part, they want us to sketch a graph. So this is something that they bring ever so often as well, right? They want us to sketch the graph. Now, since if you look at this here, you can easily tell, since this is positive, this graph has a minimum value, right? Now the thing is, you know where the graph is cutting your... The graph is cutting at 0.71 and 3.29. So this is your graph. This is X. This is Y. This is 0.71 here. Right? This here is 3.29. Right? And they also want us to put in the axis of symmetry at the minimum point. So your axis of symmetry is going to be this line here. This is your minimum point here. Could you all tell me what are the coordinates of the minimum point? What is this coordinate here? That minimum point. The quadratic looking like a oh. Alright, so I've seen some people put in the coordinates of their minimum point, right? So guys, once you complete the square, right? What's something here? This point, the x value of your minimum point, you just need to put x minus 2 equal to 0. So this point here, right? So the axis of symmetry is x equal to 2, right? So this coordinate is going to be 2, and the y value is simply minus 5. So it's 2 minus 5. This is something that CSEC loves to bring in the exam, guys, right? So it's 2 minus 5. So that's a simple sketch there for your quadratic. All right, guys. So it is already 10 o'clock, right? This is as much time as I have to give up you guys freely, right? Like I said, you have 6 questions. You have 2 hours and 40 minutes. I just want to wish everybody good luck in the exam tomorrow. Try not to be scared. Answer the questions that you are comfortable with first, right? Don't spend more than 20-25 minutes on a question, right? Because you have to manage your time. You have 6 questions to do here. Please walk to the exam with a working calculator, right? Make sure you have enough pencils, make sure you have eraser, make sure you have enough pens as well, right? I have a tendency to go into an exam and my pen stop writing, right? What else? Right, some people saying, yeah, so I can only go till 10, guys, right? I actually had a Form 4 Ad Maths class earlier from 5 to 7, right? So guys, just remember to hit like and subscribe, right? My new Form 4 Ad Maths class will be starting in August, and that is for students who will be writing in 2025, right? All right, guys, so that's it for me for this afternoon, right? Enjoy the rest of your night, guys. Good luck with your studying, right? Be safe, and you all could let me know how the exam was, all right? Take care, guys.